This is a 10-story building erected in just over 24 hours. It's designed to withstand massive tremors, equivalent to a 9.0 magnitude earthquake, with a lifespan that can reach hundreds of years. Yes, you heard that right. This project is the real deal, built by a Chinese company called Broad Group using their proprietary engineering. With its lightning-fast construction and long-term durability, this technology is expected to revolutionize the building industry. Stick with us in this video as we break down the process behind it. And don't forget to hit like and subscribe if you enjoy exploring construction marvels like this. The exact construction time was 28 hours and 45 minutes for the entire building. The breakthrough idea here is simple. Building a house should be just like assembling a car. Technically, the building was assembled at a site in Changsha, using multiple cranes and a large workforce. However, every single part was manufactured in Broad Group's factory and transported by truck. It's almost like playing with giant Legos. Workers no longer have to endure months of rain or scorching sun at a construction site. Sounds ideal, doesn't it? But to make it work, the first and most critical step is standardized design. This is where engineers turn the entire building into mass-producible blocks called modules. These modules are made from the company's exclusive BCore steel plates. They are built to the same dimensions as a standard 12-meter, 40-foot container for easy shipping. They use high-strength steel, specifically Q460 or S460 grade, which is strong enough to handle massive loads while keeping the overall weight of the module in check. The steel plates used for the floor beams are typically 10 to 20 millimeters thick, while the main columns and beams can be up to 20 to 30 millimeters thick. These components are fed into advanced CNC plasma cutting lines that can handle lengths up to 13 or 14 meters with a cutting margin of error of only about 0.8 millimeters. During the cutting process, every welding spot, bolt hole, and connection point is pre-marked according to the blueprints. The entire process is automated and closely monitored by technicians. Once finished, each component is tagged with a tracking code and sent to the frame welding station. First, the steel columns and beams are placed into a fixed jig to maintain perfect dimensions during welding. This ensures the frame stays square and straight without heat warping. They primarily use MIG or submerged arc welding, SAW, with parameters pre-programmed based on the steel's thickness. To prevent warping, welding is done in a symmetrical sequence, alternating sides of the frame. After welding, the frame's alignment is checked. The allowable deviation is usually less than 3 millimeters. During this stage, gusset plates and reinforcements at the corner columns are also welded on. These are the critical connection points where high-strength bolts will join the modules together during assembly. The finished frame is designed to handle a dead load of about 3 to 4.5 kilopascals and a live load of 2 to 4 kilopascals, meeting real-world usage standards. Finally, critical welds are inspected using ultrasound or X-ray to catch any internal defects. Once the steel frame is complete, workers install the structural flooring to create a rigid deck for interior finishing. The exclusive technology used here is called BCore. This is a stainless steel sandwich structure consisting of 2 parallel steel layers joined by hundreds of small steel tubes. These tubes undergo a copper brazing process at over 1,100 degrees Celsius, 2,000 degrees Fahrenheit, in a specialized furnace to create an incredibly strong metallic bond. A typical BCore panel is about 15 centimeters thick. With specialized machinery, a standard 12 by 2.4 meter panel can be produced in just about 2 minutes. The key advantage of BCore over traditional concrete floors is this. It's about 10 times lighter, yet it delivers the exact same stiffness and load-bearing capacity. This significantly slashes the total weight of the module, reducing the stress on the building's frame and foundation. Once the frame is set, workers move in to install the electrical, plumbing, and ventilation systems. These modules use a plug-in or quick connect design, meaning once they arrive at the site, they just need to be snapped together. According to industry data, about 70 to 90% of the MEP, mechanical, electrical, and plumbing, work is finished in the factory. This cuts down on installation errors and reduces on-site construction time by 30 to 50%. Next comes the installation of the walls, soundproofing, and insulation to turn each module into a complete living space. The interior and exterior walls use BCore sandwich panels about 21 centimeters thick. These provide the same insulation as a thick concrete wall, but at a fraction of the weight. After a final quality check, the modules are packed and shipped to the site. The beauty of this system is that while the modules are being built in the factory, the foundation is being poured at the site simultaneously using traditional methods. Once the foundation is ready, the modules are craned into place, stacked, and connected. The margin of error at the connection points is usually just a few millimeters, so workers basically just drop them into place and tighten the bolts. No on-site cutting or welding required. This method moves 90% of the work indoors, pushing construction speeds to levels we've never seen before without compromising quality. Thanks to 22 centimeters of insulation, triple-pane windows, and a smart heat recovery system, the energy costs for a building like this are only 1/5 to 1/10 of a traditional building. Now, this one-day construction feat might sound too good to be true, but it's backed by a proven track record. The company previously set a world record with Mini Sky City, using the same modular assembly. That's a 57-story building, standing 204 meters tall, finished in just 19 days, faster than any high-rise in history. They even live-streamed it so the world could watch it happen in real time. That success was possible because 2,736 modules were prefabricated in the factory, accounting for 90% of the total structure. This allowed a team of 1,200 workers to assemble the building at an incredible pace, an average of 3 floors per day. Mini Sky City holds about 800 apartments and office space for 4,000 people, with a total floor area of over 180,000 square meters. With a construction cost of about $1,000 per square meter, which is 20 to 30% lower than traditional methods, this tech is gaining some serious traction. Plus, by minimizing the use of cement, it's a much greener way to build. Countries with extreme weather like the UAE are already showing a lot of interest because of its high heat resistance. When construction shifts from pouring concrete on site to assembling in a factory, speed is no longer limited by the weather or manual labor. This could be the biggest shift in the industry this century. What do you think the future of construction looks like? Are we about to see mega projects popping up all over the planet in just days or even hours? Let us know in the comments. Don't forget to like and subscribe to stay tuned for more projects like this.